Hello everyone, welcome to the second episode. The first episode got promptly ended by my parents' cats because I'm actually recording this from my old desktop at my parents' house, and because they're on holiday and I'm watching the cat. So yeah, we were left off at categorizing both Kepler and Galileo firmly in the experimentalist portion of things, if you will. The only thing that Kepler did was he took the things that he knew from observation is the key word here, and put the mathematical formalism behind it. Yes, he created a model with that, but experimentalists can create models and do create models all the time. The only thing I can do is put him a bit more in the kind of data side, but that's like still Kepler is very much on the experimental side. So out of the three people you named so far, with Bruno being a natural philosopher, I've not written him down yet because he is not exactly important for the history of both astronomy or like physics, but just to be complete. So yeah, out of the four people you named, like none of them are really theorists.
Or Isaac Newton, whose cannon shooting thought experiment gave rise to...
Now, with Newton, I guess I can give you Newton as a theory. Well, he also made some experiments, right? Okay, so his optic things pretty much come from experiment. You can see it here. No theory needed for that. But with mechanics, yeah, okay, I can give you Newton somewhat, I guess. Newton really was everywhere at like, because he was flipping Newton. Newton did like everything, I guess. He made experiments. He was also a natural philosopher, not exactly a good one, but he was. So yeah, okay. Newton is fine.
Gravity or Christian...
Gravity is not a theoretical concept. It was just an observation. You know that if I describe something with mathematics, that's not theory, at least not theoretical physics. You have a very poor understanding of what theoretical physics is.
Huygens, who in 1653 came up with the distance from Earth to the Sun when he guessed, yes, guessed, they say correctly by chance, the size of Venus.
Yes, that's also an experimental thing. He made an observation to get another measurement. That's like the kind of the definition of experimentalist. You really have a poor idea about what theory is. I'm like, Huygens was very much a experimentalist as well. Now, you're correct that he guessed, absolutely important, right? Exclamation mark. He guessed that Venus was the same size as Earth. But that's what you do sometimes in astronomy, you know, especially in those early times. You know it's a planet from telescopic data, early telescopic data. You have no clue how far it's away. You have no clue how big it is. You only know the size of one other planet, and that's Earth. So you can, which is like, that's leaning very much out of the window, you can assume that that's the only reasonable thing Huygens was able to do, that Venus is the same size as Earth, because the one planet we know is exactly the size of Earth. That's a very, very, very big stretch and a very huge assumption. But because we don't have any other data at that point, when Christian Huygens was around, that's something that you can do. And he was very lucky with that guess, because he chose the planet that is actually closest to Earth in size. Like within our solar system, of course. But it was a lucky guess, yes.
Allowing him to measure the Earth to the Sun distance. Or Father George Lemaitre, the Jesuit, who came up with...
Now, that's a theorist. Lemaitre is a theorist. Thank you. Finally, the first pure theorist. I think you write him like that, don't you? Yes. Lemaitre is a theorist. I'm glad with that classification. Lemaitre was very much a theorist.
The idea of the Big Bang.
In principle, yes. Now, Lemaitre was really, just to get a brief overview again, I can't type. It's horrible. I'm so sorry. There are multiple Lemaitre's, apparently. Yes, exactly. George Lemaitre. He was a theoretical physicist. You got that one right. He concerned himself with relativity, as a matter of fact. Relativity being very much a theoretical subject, apart from the astronomical implications. Did he do anything else? Just briefly, yeah, general relativity and later stuff that Hubble observed. So yes, the first one you got right. George Lemaitre being a theorist.
The Earth to the Sun distance, or Father George Lemaitre, the Jesuit, who came up with the
I don't see how it's important that he was a Jesuit.
idea of the Big Bang, or Henry Cavendish, who used balls in his shed to correct.
That's another experiment. That's you're literally naming the experiment and calling him a theorist. Cavendish, however, was a mixed bag. Like, from only the thing you mention, you could ascribe him as an experimentalist, right? But he was more. They are listed here as a natural philosopher, because at the time those two things were very much still connected. He was also a chemist. His chemistry stuff, as far as I understand, he made mostly experiments. Now with his other stuff, I'm not too familiar about, to be quite real with you. He came up with quite a bunch of things that were, as it says here, not known until collected and published by Maxwell, which quite a bit time after his death. So he did a lot more things than we thought that he did originally. But he was still more on the experimentalist side. I will give you with the things he did in electronics that he those can be ascribed as theoretical, but other than that, Cavendish was really more on the experimental side. He was also a natural philosopher. Cavendish did a lot of things, actually.
Come up with the mass and weight of the Earth, or Max Planck, who was the originator of the quantum theory.
Yes, Max Planck. There you go, another classical theorist. Max Planck, the pure name sends shivers down my spine from all his complicated stuff that you need to learn in bachelor's and the masters of physics, because everything that man touched was really complicated. I would argue precisely because he touched it. That's one of the people that if something in physics is named after him, you will probably have a bad day thinking about it.
Theory, or Albert Einstein in relativity and the bending of space-time.
Yes!
To more recently,
Einstein, the most classical theorist that you can have. Albert Einstein. Although, important to mention, Einstein early on did a couple of experiments. I just thought I'd mention that. Einstein was everywhere in physics. You stumble. When I started studying physics, I expected Einstein to be like in relativity and possibly like in theory somewhere. But I found Einstein in almost every course I took, from aerosol physics to like solid state physics to nanotechnology. He's everywhere. He did everything in physics. One of our astronomy lecturers actually said that if it's a lecture and Einstein's not in it, you did something wrong. So yeah, Einstein's everywhere. He did fucking everything.
Lawrence Krauss, who tells us that something can come.
I'm not sure if Lawrence Krauss is a theorist. Also, he's not important. He's just well known. That's something that flat earthers do a lot. They think that the people that are well known are important. But Lawrence Krauss is okay. He's a cosmologist. Okay, well yes, then they're a theorist. Yes, but like a lot of these people that they know aren't exactly important. They are popular. Some of them are even science communicators. I wouldn't put Krauss on the list because, frankly, in comparison to all of the others, except for maybe Bruno, Lawrence Krauss didn't do anything of importance, so I will not mention him here. But yes, he's a theorist. You got him right. Theorist, yes, I agree.
From nothing, if you have gravity. Or Michio Kaku, who tells
I know that he's a theorist, but I will also not put him on the list because he's not important.
us all about string theory. Of course, there are thousands more. To see a pretty decent list,
Yes.
check out the link in the description to Wikipedia, where you can see the many other names like Stephen Hawking, Richard Feynman, Ernst Mach, Max Born,
Ernst Mach was kind of
Ernest
both.
Rutherford, James Clerk Maxwell.
Yes,
The
Maxwell
list goes
was
on and on.
But
But I want to come back to one in particular to help us answer our question, and that is Michio Kaku. In a recent
I have guessed so from the title. Am I smart? Like, I mean, come on.
interview, Michio Kaku said the following. Now listen carefully, as I believe he gives us the answer pretty much straight up.
You're not going to believe this. In science, we always say that you make observations, you have a theory, you go make more observations, and it's a very, very tedious process.
That's not what we say in science. That was a simplification to the point of it just being straight up wrong. I don't think I need to tell you about the scientific method. You should have heard that like 27 other times from all of the people you have talked to. But if you want to hear it specifically from me, I can do so. You start with either a hypothesis or an observation. I'm not going to give you the child version of scientific method, because we are all grown-ups here. So you start with either an observation or an hypothesis. Either is fine. If you start with an hypothesis, you then collect data to see if the data can fit the hypothesis. If it does, or if it fits like extremely well, you can call that a law. For example, like Ohm's law. And if you have a kind of a superstructure over it that explains a whole bunch of laws, that explains the mathematics behind it, that explains almost on a I'm hesitant to say philosophical side here, because it's not philosophy, but that puts a framework around it, like general relativity with space-time thing, right? That's the framework around it. That's a way of describing a whole bunch of processes. That's what space-time is, right? And that's a theory. What he says here is
Observations, you have a theory.
You have observations, you have a theory. That's so vague and so oversimplified. It is
observations, wrong. And it's a very, very tedious process.
The tedious part, I agree with.
Wrong. Nobody that I know of in my field uses the so-called scientific method.
That is correct, because the scientific method that is usually taught in like middle school or early high school is somewhat rubbish. What you do mostly, like a lot of things revolve around collecting data, at least in my field.
In our field, it's by the seat of your pants. It's leaps of logic. It's guesswork.
Sometimes it is, yes. Especially in the more theoretical subjects, right? They essentially, like, to me, to someone who's not a theorist on a high level, it sometimes seems like the theorists shoot at the wall and see what sticks. Which I honestly don't think that that's the best approach, but technically it's still science, because later then the observation will determine which of them were right.
In that quote, I believe we find our answer. He said, plain as day, that nobody that he knows of in his field, and his field is theoretical physics.
His field is string theory. String theory is a part of mathematical physics.
Uses the so-called scientific method. Why is it so important? Well, it is so important because when we look at the definition of pseudoscience, we see clearly and everywhere that by definition, pseudoscience is a collection of beliefs or practices mistakenly regarded as being based on the scientific method. Yeah.
But it is based in the scientific method. He just doesn't use the scientific method himself. Physics and most sciences in general today are so specialized that one single person is, like, without a few very rare exceptions, never going to go through all of the steps. You're just going to do one of the steps. Like, you just do the experiment, or you just reduce the data. That's what I'm doing for my master's thesis. I'm not interpreting anything, I'm not observing anything, I'm just getting the data from someone else who did the observations a couple of years ago. I get all of the data, I do the very tedious statistical analysis of over 2,000 different observations, and I see what I can get out of the statistics in the end, and I hint at possible correlations. That's not a theory yet, that's just me saying, hey, the mass of whatever increases with the luminosity or something like that. That's not theory, that's just what you get out of the data and the tiniest bit of interpretation, right? That's what you usually do. And one person usually sticks to one of their fields. So the theorists will only the theorists will only create mathematical frameworks for all of the data that is put together by other people. The data scientists only analyze data that is made with observations and then later put to the theorists. The experimentalists in astronomy, those are the observational people, only make observations. So when he says that no one in his field follows the scientific process, that I either it's because he's in mathematical physics, and mathematical physics is a bit different, where they essentially guess mathematical frameworks and see if they can derive fundamental laws out of these mathematical frameworks to make calculations easier. Or because I think I just because I'm interested, is he a mathematician or is he a theoretical physicist? He's a popular scientist for sure. Okay, he's a theoretical physicist and futurologist, whatever the fuck that means. Sorry, I kind of disagree with that being a thing. I'm just interested in what he did so I can get a better... Yeah, string theory and quantum field theory. Okay, he's that kind of person, I see. So string theory is more of a mathematical construct that is not even claiming to describe, like to describe nature accurately. What string theory is a lot of people in string theory say it's not supposed to be accurate. It's supposed to be kind of like a calculational aid, something that you can make calculations with better than we can currently, right? Quantum field theory, I honestly don't know too much about quantum field theory. I'm not a big quantum person, and quantum field theory is quite advanced. I did intro to quantum mechanics, particle physics, and advanced quantum physics, which is the only subject that I ever failed. Even in advanced quantum mechanics, we didn't talk about quantum field theory. So that's like very much on top of what you can learn about the quantum things. So I'm unsure if quantum field theory falls into this framework as well. I think it does. Yeah, so not to mention that all of these are on the very frontiers of science as we speak today. So I don't think you have a point here. The point here that you are trying to make is that those don't adhere to the scientific method. But they are, as being a part kind of the scientific method, is the underlying mathematical model, like description. But we just don't know if the description is accurate yet. We have no idea. It could be, could not.
Yes, pseudoscience consists of statements, beliefs, or practices that are claimed to be both scientific and factual, but are incompatible with the scientific method.
Note that all of these people, I just noticed it now, note that all of the people that Sharon has in his video here think that the Earth's a globe. Just mentioning.
One more time, in case you missed it, from Michikaku himself.
Wrong. Nobody that I know of in my field uses the so-called scientific method.
And when you don't use the scientific method, what you practice is no longer called science. It's simply called pseudoscience.
In our field, it's by the seat of your pants. It's leaps of logic. It's guesswork.
Yes, sometimes it is guesswork, like assuming properties of a particle. But you can still make a valid hypothesis with that. And the hypothesis can still be proven or disproven. Now, if you want to get into the pseudoscience thing, I have a suggestion. There is this extremely nice page somewhere. I've forgotten it. I believe it's from a EDU site. Is it that one? Or is it a book? Don't want to read a book now. I think it's loading a book. Yeah, no, that's probably not the one I was looking for. I will just get it off here, although that's not the thing that I wanted. You can identify pseudoscience from these things, right? So is theoretical science in fact pseudoscience? Is it falsifiable? Yes. Does it rely on anecdotes? No. Is it cherry picking? Individual theories sometimes don't necessarily cherry pick, but they they choose a specific like thing of stuff that is like, they choose a specific way. They assume that a particle has this and that mass, even though the jury is still out on it. That's not cherry picking. That's just making an assumption. So I don't think that that's cherry picking. Technobabble, no. All of the words have to be defined very, very precisely and are defined very precisely. Lacks plausible mechanism. Sometimes, yes. But that's the thing in like the frontier of science, is that you can't cite the mechanism sometimes because we just don't know. We are finding it out as we speak. Is unchanging? Well, very much not. That's the big thing. It's not unchanging. Very important. Self-correction is one of the most important things, I'd argue. Extraordinary claims depends on what you would say. Depends on what you would define as extraordinary. I don't think that the claims are necessarily extraordinary, but extraordinary in a scientific sense is ill-defined. Certainty, no, not at all. Logical fallacies, possibly. That's more a thing of the scientist and not of the thing itself. That's more like of a if someone is making logical fallacies, it's most likely the scientist, because those just happen sometimes. Lacks peer review, well, very much not. They're within a scientific field. The only thing that makes it scientific at the end of the day is peer review, and they do not claim conspiracy. So they don't really fulfill any of the classical characteristics of pseudoscience. And with that, I believe I will leave it for this episode. If you enjoyed it, I forgot to say my stereotypical last words at the last episode. I'm so sorry. If you enjoyed this video, do please consider leaving a like. If you enjoyed this video a lot, please do consider subscribing. Possibly considering subscribing even. And with that, I will see you in the next episode, and have a nice day. Goodbye!